Hey, welcome everybody to Activity for Processing 3.3. This is going to help us tackle this exit card. So it's a mini lesson. Um, as always, if this mini lesson doesn't quite suit you, to complete this exit card here, there will be some resources linked into the lesson 3 topic in your Google Classroom. And if those links don't work, my video doesn't work, you're always welcome to activate your own style of learning. You can look up Google for any videos that work for you, any articles that work for you to answer these. So today we will be emphasizing two items. These things called exponents and we're also going to be emphasizing radicals and how to go back and forth between these two forms here. So let's go ahead and begin with question 1. Question 1 is asking us to write a solution to the equation x to the second power equals 5. Question 1 right here, okay? And it's asking us to do it in two different ways. Either to use an exponent representation or a radical representation. So for the sake of today's mini lesson, here, let's jump into our example. So we want to find the value of x using exponent representation, and I'll put the work for that here on the left side. And then we're going to do this equation, find the value of x using a radical representation on this side. So here's how you do it using an exponent representation. So in order to find the value of x, I technically need to get rid of this exponent here. That must have an exponent value of 1. So at the end of this, we need to have x to the 1 equals something. In order to get from this step to this step here, we need to find a way to change this 2 into a 1. Here's how you do it. You can raise the power of this expression x squared to the half power. And if you raise the left side of the equation to the half power, that means you're going to have to do that to the other side of the equation. So you're wondering to yourself, what do I do with this here, right? Well, whenever you have this thing called a power of a power, you multiply the exponents. Here the exponents are 2 and 1/2. 2 times 1/2 gives you 1. We are now done with that here, okay? So if you're wondering how did 2 times 1/2 equal 1, I'd like to do that little extra math here. So we're officially done with the problem here, but I'd like to show you the extra calculation. So how does 2 times 1/2 become? So you multiply the numerators 2 and 1 and you get 2. And you multiply the denominators 2, and there's an invisible one here. You get 2. 2 divided by 2 means that this fraction, 2 over 2, reduces to 1. Okay, so that's how you do it for a exponent representation. Let's go ahead and hop onto this side over here, a radical representation. So on this side, we want to use this thing called a radical. That's called a radical. And you can put an index value in the radical here that is identical to this index value. And if you take the square root of the left-hand side, that means you have to take the square root of the right-hand side. So you see this equation has now changed into the square root of x squared and the square root of 3. So we have just effectively taken the square root of both the left side and the right side. Check this out. Okay. Now I could have chosen in the index value here, but if you're being smart about it, there's a rule that we've covered that lets us know that these twos, if they are identical, your index and your exponent, if they're identical, they cancel out. So our answer is going to be the square root of 3. Now, I'd like to add a little more spice to this here and make you really think. Okay, this is one of those pause opportunities. So here, go ahead, take a moment to pause the video. I won't, I'm gonna keep talking, but pause the video, time out. What do you think is special about these two representations? Well, they are the same. This is called an exponent representation because this thing in the corner is called an exponent. This is called a radical representation because there's this radical symbol here. So exponent representation, radical representation. They look different, they appear different, but they have the same value. Okay, let's go ahead and hop into our CFUs here. Okay, so my first question to you here is, if we have x squared equals 11, and I ask you on this side to represent it in exponent form, can you find the value of x using exponent form? Pause the video, try it out, and then I'll go ahead and work this out. Okay, so if you got x equals 11 to the half power, you're good there. You know how to do it in exponent form. Now on this side, let's try it using radical form. So go ahead, pause it here. Try to represent this equation, the value of x, in radical form. All right, here we go. All right, cool. So if you were able to get 11 to the half on your own, and if you were able to get the square root of 11 on your own to represent your value as with exponents, or your value of a radical, you're in good shape. If not, always, I'm gonna encourage you, obviously show up to class through the Zoom call, or show up to office hours with the Zoom call and get yourself some help. Okay. So that gives you enough information to write a solution using exponents and to write a solution using radicals. The last one, we need to write the cube root of 78 using exponents. This one's a lot easier compared to these two, in my opinion. So here's a few to get you started here. What was the other one? Fifth root. I'm getting fancy here. I'm using different index values. I remember why I was doing this now. Okay, so these are all radical representations, and we're going to change them into representations that have an exponent. That is it. It's that easy. But let me show you why it's easy though. Let me show you, because you're probably thinking to yourself, this index, just put it in the bottom. I get it. Just put it in the bottom. But where is that one coming from? Simple. It was there the whole time, it was just invisible. Because 75 to the power of 1 is 75, it's safe to write 75 to the first power. So you put the exponent on the numerator position and you put the index in the denominator position and you're good to go. So let me give you your last round of CFUs and see how you do here. So let's do cube root of 103. Let's do the fifth root of 103. And then let's try the 10th root. This is not gonna be on the cooldown, but I just wanna put this here for the sake of challenging you. 103 to the second power, okay? Okay, so this is your opportunity to pause the video, try to work these out on your own to put them from radical form into exponent form. But I'm gonna go ahead and do this. I'm gonna assume you're pausing. Then when you come back, you should be getting these answers. If you got this last one to be 2 over 10, great job. I'm gonna push you just a little more here. You can reduce 2 over 10 into 1 over 5. It's just a good habit to reduce your fractions, right? All right, so that brings us to the end of this video. We have, I have done my best to present enough information for you to not only look at, experience the scenarios here, but to actually try out some of your own problems, okay? That's all I'm gonna say about that. So I'd love to see you during class. I'd love to see you during office hours for extra help. I don't want you to look at this video, read the resources, or even take your own path on Google or the internets. Come back empty-handed, okay? So help yourself so I can help you. Much love. I'll catch you guys next time on lesson 4.